Okay, so we've been working through with our maze solver here, and our next step now is we're going to build something so that we can do have the maze solve itself. And so we're going to make a function called auto solver, and so we'll call it here auto solver, and then we're going to define this function down at the bottom, and so we'll say void auto solver. Okay, and what we're going to do is we're going to make a okay, yep. So what we're going to do is we're going to make an array or a list. Actually, for that, we're going to make a type to hold or a move. So we're going to say type def struct. We'll call it, and this, a struct is basically a way of organizing data in C and C++. And so like here, we have these four values: the direction, the offset, the center, input, and servo center. We could have put all these together in a struct to help us stay a little more organized there. And that's something we can change in the future. But here we're going to make a struct for tracking the movement. So servo movement type. Let's do underscore our lowercase m. Okay. And what we're going to do is we're going to have int x, int y, and delay. And what this is going to be is, say delay milliseconds. And what we're going to do is we're going to use this, so we have to say the type again right here. And so basically we can just do this right here, but then every time we declare it, we have to declare it using these two words. And so having the type def allows us to declare with that. So we're going to say servo movement type, and we're going to make a list of these, or an array. Maze moves equals, and now we're going to make that array. Okay? And what we do is for each item in the array, we're going to say the X movement, the Y movement, and the delay, so how long to wait. Okay, and so then you can solve your maze this way by creating a series of these movements. And what will be is these, the Y and the X will be like distance from center. Okay, so 0, comma, maybe like -10, and for like 200 milliseconds. And so basically the way this works is we're going to have this is X, the Y, and this is the delay, right? And you can make as many of these movements as you want that you need to solve your maze. Okay? And so now what we're going to do is we're going to say int. First we're going to add a short delay. We'll say int num moves equals size of maze moves divided by size of maze, or we'll say servo movement type. So this tells us how long our array is, so you don't have to count it yourself. What this does is there's a certain amount of memory set aside when we create this array, and it's calculated based on the number of items in there, and then each of those items uses up this much memory. And so if we know that we have this much total memory and this uses up a certain amount of memory, then it's going to divide those. And so here you could see this is 12 This comes back, it has a size of 12, right? So there's 4 of them, each of these is 4 bytes. And this comes back with a size of 24, right? Because there's 2 of them in there. If we add a third one, now you'll see this is going to have the size of 36, okay? And so on. You can't do this in the web ID, but on the desktop one you can. Okay, so we got our number of moves. We're going to add a short delay, maybe of like, let's do this. We're going to blink the LED on the board to say it's getting ready. So we're going to say for int I equals 0, I is less than 3, I plus plus. We're going to say digital write 13 comma high delay 500, and then we'll do the same thing to turn it off. And the purpose of this is so that we know that basically it's going to blink for 3 seconds here to show that it's about to start. And so, and if you need to make this longer, maybe we'll do 5 seconds. And this will, gotta set the pin mode. The purpose of this is so that you know it's getting ready, and so you can put the ball in the right spot. And then if you miss it and you need to start it over, you can just press the reset on the button on the board. You'll see it blink again, and then it'll start again. So there's output. Okay. All right, so that is good. And now what we're going to do is we're going to say, so we've figured out how many moves, we've got our pin modes, we've got our loop here to give us a little minute to wait, and now we're just going to solve it. So say for int I equals 0, I is less than num moves I plus plus, and all we're going to do is we're going to say x servo x axis servo dot write, and we're going to say x axis servo center plus maze moves I dot x. Okay, so we're going to start from our center, and we're going to move forward or backwards depending on what the size of this is. And so basically I is going to get the part of the array. So for here it's going to be, this would be 0, it's going to grab 10, and then be 0 for y. And then so we add a semicolon here, and then we're going to copy this, and we'll paste it. We'll do the y-axis servo as well. Okay, and then we'll delay maze moves I dot delay milliseconds. Okay, and so now if you can continue to expand out your moves. So maybe you want to go now to 0 and like 10 or something. Maybe like do it a little bit longer. And so you can kind of build it out from there. You can add more, as many as you need, you know. And so now we've got that. And then you may run out of space at some point. So let's verify this, see if we made any mistakes too. But this will tell us how we're doing with memory, because we want to also make sure we don't run out of memory. Looks like we have an error. This library only supports. Oh. That's funny. Okay, so I got the wrong board selected. Okay. There we go. Okay, so now we have an x-axis servo. So okay, so it's just x servo center and a y servo center. Okay. Oh, and we have a typo right here. Type def. Okay, looks like there was something else too. Maze moves. Let's see if that fixes it. Okay, there we go. Okay, so we're looking like we're doing okay with memory, and so let's add a couple more and see how it changes. Okay, so we made our list like very long, and you would again adjust these to be whatever moves you need, and you could change the lengths of them. But now, yep, okay, yeah, we're pretty good on memory then, so it doesn't use up too much memory. And then, if you don't want it to, when this function is done, when our auto solver finishes, it's going to go back into normal like function. And then if you want to turn the auto solver off, you can just comment that out, and it won't do the auto solver anymore. Okay, so this is how you build that, and the majority of the time here is going to go to like kind of tweaking it, getting your directions right. You have to think about what you want those angles to be. So you want to keep these relatively small. So whatever your max offsets, where you would try to keep them within that, and then yeah, you kind of figure it out, and so you can be a little bit more subtle here. See, once you get it working too, you can kind of see if you can speed it up and make it go faster. Okay.